Amazing. And let's just start as people join, as we wait for people to join. Can you just tell me your developer experience in terms of how long you've been in Web3 and also how you came to start developing on Lisk? And also if there's anything you hope to learn today. Feel free, whoever wants to join in. This is an open discussion, so I want anyone to feel comfortable talking and speaking while we learn. Don't be shy. Does anyone want to jump in? All right, we're going to give it a few more minutes as people join. And then Pope, if you can just do an introduction about Lisk and Secret and these workshop series.
Oh, sure. All right, so welcome everyone. So on today's workshop, so we'll be learning how to integrate Secret confidential computing layer. And today we'll focus on WalletConnect. So Shinra, who is our dev at Secret Network Foundation, will be taking this workshop. Please do feel free if you have any question, do feel free to ask. And I believe some of the hackathon winners should be on this call as well. So probably you guys might want to talk about what you are building on links and how you intend to integrate Secret confidential computing layer. And remember, there is a price for integrating Secret confidential computing layer. That's for those who will be joining the Act Secret. There's about $5,000 in reward as well. So after winning some prizes from Leaks Africa, you also get the opportunity to also win prizes from Secret Network as well, if your dApp qualifies or meets the requirements. So yeah, let's hear from builders here. What have you been building on Leaks? How has the hackathon been at Leaks? And tell us about your experience as well. Please, anybody can go, feel free, this is an open space.
Maybe Jordan can go first.
Okay, awesome. I believe he's the devil, right?
Yeah.
Awesome.
Can,
Nice to meet you.
okay, nice to meet you. Hi, everyone. My name is Jordan Modemba, and I'm a smart contract developer and part of the DLT Africa, and which have partnered with Lisk to be able to organize hackathons and workshops like this one. Yeah. Someone else can do so.
Okay, Jordan, can you tell us about some of the applications being built during the hackathon? So, or probably the devs building it can also give us an intro about the dApps they are building. I believe today is the submission date.
Oh, okay, yeah, sure. I can do talk about it. So we have a number of projects varying from DeFi, DePIN, that is decentralized physical infrastructures, real world asset application. We've seen quite a number of people building on that, on DeFi, and also on tooling. We have a number of projects on tooling, specifically to be able to help developer be able to build on Lisk. And I think that is what also the secret network is doing. So this project, once the hackathon has or the judging has commenced, some of them can actually join the secret network to be able, the secret network Africa, to be able to hack on the hackathon you guys are holding. Yeah. And I think one of the most important part about this hackathon is that we've had like 2 months of training developers, both in Kenya and Nigeria, where we trained developers in various ways of building smart contracts on Lisk, and why it's important to be able to build scalable applications that use Layer 2 solutions. Yeah, that's the much I can say about the dApps that have been built and the categories and the fields that developers have been able to build this application. So we had like 31 submissions so far, which is really amazing.
Wow.
Yeah, that builders are building, and they are very eager to adopt to the technology. There is technology. Yeah.
That's amazing. Yeah, 31 submissions is great.
Yeah, that was awesome. Good to hear.
Actually, it's 36 right now. Yeah, shooting for 40 probably by end of day. Judging has started today. We anticipate judging to go on until Wednesday or Thursday. Then announce winners probably on Friday this week. Yeah, so shooting for 40. Let's see how it goes.
Amazing.
Hi,
All right.
GM everyone. I am Noim Oluide from Nigeria. I am one of DAT Africa, and I happen to be one of participants of hackathon, which I work on e-commerce, and I have submitted my own project. I heard about DAT Africa, Lisk, through DAT Africa. Uh, like I said, I am part of DAT Africa, and I'm able to participate in hackathon as well. Thank you.
Amazing. All right, does anyone else want to intro themselves before we jump in?
Hi, GM everyone.
GM.
Are you guys hearing me?
Yes, we can hear you. Sounds good.
Okay, cool. My name is Amasol from Nigeria. So I'm one of the DLT team whereby we partner with East Africa. Yeah. So I'm curious to participate in this hackathon you guys are talking about. Yeah. So currently working on the solution. Like it's not really found. It's going to like a solution in form of e-commerce, anyway, any quality e-commerce solution. Sure. So that's the solution I'm working on. So close to be able to deploy the contracts, the solution on the chain you are talking about and participate in your hackathon. Right. Thank you.
All right, let's dive in. Can somebody link to the Lisk hackathon in the chat just so I can see what you guys are working with? The goal for today.
Yeah.
Perfect. So the goal for today is I want you to understand Secret Networks Hackathon that's ongoing right now until June 20th, and how you can create cross-chain dApps using Lisk and Secret to be eligible for this hackathon. We have $8,000 US in prizes that are available for eligible projects. So I think what you learn on this workshop today and the one that we're doing later this week will make it so if you update your dApps with this logic, you will be eligible for this prize to be able to submit to the Secret Network Hackathon as well. So the goal for today is just showcasing Secret Networks Hackathon, firstly. Secondly, I want to show some demos of dApps that you can build cross-chain using Lisk and Secret. And then lastly, we're going to do an actual code walkthrough of how to integrate Lisk with Secret Network so that you have the resources you need to be eligible for this hackathon. So I'm going to share my screen right now. Let us see. Let me just close out some tabs. All right. Can everyone see my screen okay? Can you guys see my screen? Can someone just chime in?
Yeah, I can.
All right, perfect. All right, so I just linked Secret Networks Hackathon in the chat. And just a little bit about me before we dive in. My name is Sean Rad. As Pope Black said, I do DevRel for Secret Network. I found my way into the Web3 space by initially winning hackathons on Ethereum. My first ever hackathon was in 2022 at ETH New York, and my team won a prize. And then I became kind of addicted to just like living off the hackathon bounty life as I continued to build and develop and hone my skills. And from there, we did another hackathon. We did ETH. We did HackFS, San Francisco online month-long hackathon. And from there, I fell into learning about Secret Network because I wanted to have private smart contracts. So I'm someone who kind of has been in the Ethereum world. Then I came to the Cosmos world. Secret Network is a layer 1 Cosmos privacy chain. We use Rust-based smart contracts, so different from Ethereum. I know you guys are all building with Solidity. And now I'm really excited because I've kind of bridged both of these worlds, because now we have this solution called Secret Path, which is a bridge that allows EVM developers, which allows Lisk developers to be able to have access to Secret Network smart contracts. So you can use Secret to have encrypted messages and also verifiable randomness on Lisk. And you can kind of think of us as like another layer, like a privacy layer. If you have any sort of messages that you want to keep private on Lisk, you can use Secret Network to be able to do that with this bridge we developed called Secret Path, which is what we're going to be learning about partially today. So yes, this is our hackathon, Hack Secret 3. As I said, there's 8K in prizes, and there's 2 tracks. There's one where you can build native apps on Secret. So that means if you're just building on Secret, but probably what you guys are looking to do is to build a cross-chain application, meaning an application that uses Lisk and Secret Network smart contracts, which is what we're going to learn how to do today. So yeah, all this info is on Dora Hacks, and I just linked this in the comments. So make sure you share that or save that for after this call. Does anyone have any questions about Hack Secret before we look at some demos that are possible with Secret Network? All right. So I'm just going to show you an example, a couple examples of what is possible with Secret and being able to build cross-chain applications. Something that I made last week is a cross-chain NFT application. So I'll just link this in the comments. So the idea of this is that you can create an NFT on Lisk and then have access and then have private information for that NFT, have private metadata that only exists in a Secret Network smart contract. This example is deployed on Sepolia, but you could also do this on Lisk just as well. So for example, we can create an NFT. So we'll just call this Lisk NFT. And the way this example works is whatever the description we write into here, it actually is using OpenAI, ChatGPT, to generate an image for us based on the description. So whatever we write is what the NFT image is going to be. So I don't know I don't even know what the word Lisk means, but I'm curious to see what if we just write Lisk Africa, what the NFT image will be. And then we can have a secret message, right? This is the private metadata that we don't want to exist on EVM that will be stored and saved in our secret contract. And then we can write a password. We can write a password that is able to make it so we have access to that private data. So let's just make our, secret message, I love Lisk. And our password, we're just going to make it Lisk. I'm now going to mint NFT. Oh, can we mute whoever is there we go. Okay, so I'm going to mint this. And then our image that is generated should be something having to do with Lisk Africa. I'm very curious to see what. All right. This is the NFT image we're generating. And then, so if we actually go to, and remember our password is Lisk, and then the secret message that we saved is I love Lisk. So we don't want to forget that for when we go back to look at this. So now if I go to OpenSea, I can actually view that NFT in our collection once this transaction goes through. Let's see. Okay, see? So now that NFT exists on OpenSea testnet, and we have that description we just wrote somewhere in here. Oh yeah, Lisk Africa. Okay. And then if we go back to this demo, we can say home, view NFTs. Now we see that it exists, that my wallet address minted it. We see the token ID. And then to see the secret information, we have to enter the correct password. So if I wrote a password that's not the correct password, it will not work. If I write the correct password, which is Lisk, that's associated with this NFT, it should reveal our hidden message. Okay. So this is just an example use case of the power of secret smart contracts, that we're able to save private data in secret contracts and have them associated with data on an EVM chain, like an NFT. And what I want us to learn how to do today is how to link Lisk with secret networks so that you can build cross-chain applications just like this. So here's another example. This is a voting example. And just before I forget, if we go into secrets docs, we have this EVM developer toolkit, which teaches you how to do all of this stuff. So if you need any help with this, if you need to come back to this for further learning resources, all these demos I'm showing, like NFTs, randomness, confidential voting, storing encrypted data, we have all these demos and tutorials here. And we have more information on this bridge as well in our docs. So I'm just going to link this here just so you guys have this before I forget. And basically the way this works is we have these supported networks, one of which is Lisk Sepolia. And so basically whenever we create an application that we want to have cross-chain compatibility, we need to point it to this public gateway address that we deployed for our bridge called Secret Path. So that's what I'm going to teach us how to do today, is how to make it so that you can make cross-chain applications that have access to this public-facing contract address so that you can then access the privacy layer of secret contracts. Oh yes, let's just check out this voting demo. All right. So what you're going to learn today is how to add this WalletConnect UI so that you can connect Lisk with secret network. So if I go here, I'll see there's all these networks here that I can choose from to be able to have access to my secret contract, which is a private voting contract. And you'll see Lisk Sepolia here, right? That's one of the networks. And all that this is, all these networks, These are just the chains that we've deployed our secret path contracts to. So that's all of our EVM testnet contracts here, all these networks, and the same goes for mainnet. Okay. And then what we're able to do is have access to any of those networks to be able to actually call contracts, call secret network contracts from any of these chains. Okay. So like if, for example, if I do this on Sepolia, where's Sepolia? Okay, I can create a proposal, a voting proposal. So just a yes or no proposal. And the way this works is that when you vote with whatever EVM chain you're using, you vote with your EVM chain, right? If it's like Sepolia or Lisk, whatever it is. And then when you actually go to, but the vote itself is encrypted. So the vote remains private, but you're actually, all the interface that you're doing is happening on your chain so that your users feel familiar with like how to actually use the UI. And then all of the encryption is taken care of behind the scenes with secret network smart contracts. So let's see if this, okay. And then we can vote on this. Obviously, Lisk is the best chain. Other than secret, we're going to vote yes. And so what I'm going to teach you today is how to add this WalletConnect modal to your application so that you're able to have an interface that connects Lisk with Secret Network. Does that make sense? Does anyone have any questions before we go further into like the actual demo? No questions? Let me just check the chat really quickly. Okay. Pope Black, do you have any questions before we go any further?
No, all good.
Okay. So let me just link everyone to this resource in our documentation. This is what we're going to be going over today. It's just a tutorial that teaches you how to integrate WalletConnect, which is this wallet modal here, with Lisk and Secret Network. So this is the written documentation that you can walk through after the call to do exactly this. All right, that's in the doc, that's in the comments. So what this has us do is clone this repo. So I'm just going to copy this from the documentation, and we're going to walk through this together. Oops. Interesting. Actually, I already have this saved in my computer, so I'm just, rather than clone it again, I'm going to just open it up. But here, this is the code base, and this is linked in our documentation. Sorry, I'm just like spamming you guys with links. A lot of learning going on. Okay, let me open this up. So this is the code that I just shared. I just already have it on my machine. And there's two pieces to this. There's a randomness contract on Secret Network. And then there's a front-end contract that allows us to request randomness. So let me just show you what the front end looks like. And I don't want this to be a tutorial of like how to use secret contracts today. It's mainly just getting you guys up to speed with how to connect this wallet modal to your apps so that then you can connect your apps with secret contracts. But All right, so this is basically just like a starter template application that you can then use to customize to write your own dApps and whatever you imagine. All that this is just like a button where we request randomness from a secret network smart contract using this Web3 modal that we connect to Lisk. And I think I was just chatting with our other DevRel, Alex. I think our relayer for Lisk is down right now in this moment. We're troubleshooting that. So I'm just going to do this tutorial on Sepolia, but later today and from going forwards, this will work for Lisk as well because it's one of our connected chains. So if I request randomness, I sign this message, and then I'm able to receive a random number between 1 and 200 is how I designed this smart contract. Let's do it again. All right, so before it was 1, now it's 125. These are random numbers we're sending cross-chain from secret network to whatever EVM chain that is requesting the random number, okay? So what I'm going to teach you now is how to just kind of go through this code to set this up. So this is already all set up, so you don't have to change anything. All you would need to do is just write a secret smart contract that you would want to connect to your front end with Lisk. So for example, this contract that we're calling from is already here deployed on chain. You could redeploy it and access this contract, but we're not going to redeploy it right now in this tutorial. I guess before I go any further, has anyone here worked with Rust smart contracts before? Because that's a whole other component of this. I'm just curious, like, what your developer experience is working with Rust as well and working with the Cosmos. Okay, we got a quiet bunch. That's okay. All right. I'm not going to worry about that then. But basically, what's happening here is every time we press this button, request randomness, what our front end is doing so look, we click this button, request randomness, and what it does is it calls this handle submit function. And what that does is it requests randomness from our deployed secret contract based on the chain ID that is currently selected. So whatever the chain ID is determined by whatever chain we're currently here, right? So if I was with Lisk, it would be 4202, because that's the chain ID for Lisk Sepolia testnet. And if I was Ethereum mainnet, it would be chain ID number 1. We can see all that logged here in the console. See, we're switching from 4202 to 1. So it's whatever chain ID, we're using that chain ID to request randomness and then call upon that gateway contract that I just showed you that's in secrets docs. So if the Lisk chain ID is currently selected in WalletConnect, if we're currently chain 4202, what happens is that when we request randomness, it points us to the EVM testnet gateway contract for Lisk Sepolia. Okay, so it's going to point to this contract in order to send the random number from secret back to Lisk. So that's if there's any questions, just feel free to jump in. I'm going to show you what that code actually looks like now. So when we click that button, the function we're calling is request randomness. Let's actually look at what request randomness looks like. So this is all of the secret path bridge logic is all happening here in JavaScript. It looks kind of scary. It's like 200 lines of code, but it's like all boilerplate code. There's almost nothing that you need to change. All that you need to know is we point this function to the contract that is deployed on secret. So this is the contract address that's deployed on secret. All the rest of this is just boilerplate code. You don't have to change any of this. The only thing you need to change is this handle right here, which is the function name that we actually want to call in the secret contract. So in the secret contract that I deployed, there's only one function you can possibly call, which is request random. And so if I were to go into the contract and look at it, we see here that if it receives this request random handle, then we call the try random function in the secret contract. And what that does is sends a random number between 1 and 200 back to the EVM chain that called that, okay? And the way we determine which chain we're sending that to is just with this really simple if logic. So based on whichever chain is currently logged in with WalletConnect, we point it to that gateway address. All right. So all this function is doing, it's like all boilerplate code. It's calling this function request random. And it's calling that in the contract that we deployed on secret. And then based on the chain ID that's currently selected, which for us is, for Lisk would be 4202, it then sends the random number. It executes that function using the chain gateway contract address of the chain that's currently selected. Okay. So that's how you would actually like basically write a function that is connected to secret, which is kind of higher level. That's more not really what I think we even really need to learn in this workshop. I just want you to have that understanding of like, if you wanted to write a customizable smart contract on secret that you then point to, that's how you would do this. What I want to show you though is just how to set up WalletConnect for Lisk. So this is the more complex stuff, but like actually setting up WalletConnect in Lisk is really simple. So all that you would need to do is just clone this repo that I just showed in the comments, right? And then if we go into our front end folder, our components, there's just this WalletConnect.js component, okay? Like in our app.js, all that we have is that button to request randomness, which we just looked at how that code works. And then we have this WalletConnect modal. And so this is how we actually set up WalletConnect so that you can have this working in your own applications, okay? You only need to change basically very few things in here. All that you would need to change is the project ID for your project. So back to this piece of the docs, the secret path plus WalletConnect integration. All you would need to do is go to WalletConnect and create a project ID. You can just sign in with MetaMask. I'm signing in with my test MetaMask account. There's this projects tab. And then from here, you can create a new project and it will return a project ID. So when you make your application, that's how you would start. You just create a new project. It returns a project ID. Then you just paste that project ID here. Then you just need to write the name of your app. So this is just a basic secret path plus WalletConnect demo. There's really nothing you need to change here unless you want to. The URL, if you deploy your demo, for example, to like Vercel or whatever the landing page is, you could just update the URL here to reflect that. But almost all of this is boilerplate. So you would update the project ID. There's this metadata object where you're just kind of writing the name and description of your app. There's this others config object, which is just boilerplate. You don't need to change any of this. Then the actual creating the Web3 modal itself, we have the option to pass chain images. So all that's doing is just linking an image. It's just a logo for the chain ID. So for example, in this example that has every single secret path application, it has every single chain connected. I just link a logo image for each of these chain IDs to make it look pretty. Otherwise, there would just be like a basic blank image here. But for example, like if we didn't want that, we could just remove all of these and only keep this for Lisk, if you only wanted to have the Lisk logo. And then the only other thing that we need to pass here is the chains that we want to be able to access. So I think if I can remove all of these, for example, just to show you. And I think it should then just return. Let's see what happens. Okay, see, so I just removed all of the chain configurations except for Lisk Sepolia. And what these are just the chain configuration. So like similar to what you would see in MetaMask. So this example, right, like when you add a chain to MetaMask, you include a block explorer URL, the currency, the chain ID, RPC URL, and the name. That's all that these chain IDs here are. Okay, I just abstracted it away into another file to keep it clean in this config here. But you'll see for Lisk Sepolia testnet, it's just this object that's the chain ID, the name, the currency, the Explorer URL, the RPC URL, which can all be found in MetaMask. It's just me taking this and creating an object in my code. And then that's what I'm passing to this chains array. And then these are all of the chain configurations that you're able to access with WalletConnect. So you can comment out all of the others if all that you want to do is make it so that your application is compatible with Secret Network for Lisk. And then from there, you're good to go. You have an application that is already set up to be able to be connected to Secret Network. All right, I know that was kind of a lot of information. Does anyone have any questions that I can answer on this call? Is anyone confused? Yes.
My question would be the process for configuring my personal dApp would be the same process that you shown us. Like if you, yeah.
Yes.
Okay.
So,
okay.
Let me show you. That's a great question, because the only complicated part in this, the part that, like, we basically made it so that the UI is really clean and it's all set up ready to go. The only complex part is if you want to build your own custom contract on Secret that you're communicating with, that's where you have to understand some like Rust smart contract logic. So let me just share my screen again, and I'll show you like, yeah, I'll show you how you would do that. For example, if you wanted to create like a password manager. Okay. So this is the code we were just looking at, but I'm just going to show it to you in GitHub. So remember how I said the front end, when we call request randomness, where is this? All right, so we click this button that calls this request randomness function, right? And if we look at request randomness, what it's actually doing is it's calling this function in a secret smart contract that we deployed. So there's this, it's pointed to this contract we've already deployed on chain on secret, which contains this request random function, okay? So this is just all boilerplate code that just basically passes this call from our secret bridge to secret network to request a random number. So if you wanted to like have a password secret contract, for example, you would just deploy that contract on chain, update this line here to be the contract address of your deployed secret contract, and then call the set password function instead of request random. So like if I look at request random and then if we go into the secret contract now, we see that if we receive the request random handle, it then calls this try random function, which returns a random number. As I said, in our docs, we have all these other examples of different applications you can make. So another example we have, it's called KV store. So storing encrypted data on secret, but you could also think of this as like a password. So if you wanted to just store, instead of, this is really vague, but let's say you wanted to store passwords, you could just do that instead. And so we have this tutorial here, which walks you through how to do exactly this. And this is configured for Sepolia, but you could do this exactly the same for Lisk. And this actually shows how to like deploy the contract itself on secret and how to set all of these variables so that you can instantiate it on secret and then set it up so that your EVM, that your WalletConnect is connected to this secret contract. So if we look at like what this contract actually is, let's just pull it up so you see the difference between the random contract and the KV store contract. Give me 1 second. Let's see. All right, so this is the link. So there's all these tutorials. The one we want to look at is encrypted payloads. Now we're just going to look at what that secret contract looks like. So this contract has two functions you can call. So remember how like just now when we were looking at the JS code, they said request random. All that you would change is you would update it with the contract address that you deploy for this contract, and you would call store value instead. And what we see is we pass the value that we want to store, a password for it, which here we call viewing key. And then I think this is just like addresses that are whitelisted that are actually able to view what the password is if you choose. You could like make certain addresses that are only able to view the stored item. But you could just think of this value here as a password instead. So basically exactly what you want to do with like a password application, this tutorial shows exactly how to do that. I'm going to link that in the comments really quickly. Are there other questions? I know this is a lot of information, so there's no bad questions. All questions are good questions.
Please feel free to ask any questions.
I want to share. There's a developer Telegram group where you can ask questions. I'm trying to see which one this is. I'm going to share this group as well, because if you guys have questions, I want you to be able to ask like secret developers how to get assistance with your secret contracts, because I know that that's a new thing, and it's like that's going to be the most difficult part about this is how to write your own secret contract. But we have a bunch of developers in our community who are here to help you. So I'm gonna share that Telegram group in 1 second so that you can ask questions should you have any. Are there any other questions? None from your side? Okay, here's the Telegram group. So if you want to enter the secret hackathon and build a cross-chain Lisk dApp, and then you start to run into questions of how to connect your Lisk application to Secret Network, this is a great place to just join this Telegram group at Secret Network Devs, and devs from our community will assist you. You can also message me on Telegram as well, at Seanrad, SEANRAD. I'm curious, does this technology seem like something you guys are interested in using? Like, are you thinking of applications that you could build on with Secret that you wouldn't be able to build on Lisk by itself? Yes, please, Jordan.
Maybe you can share from the list of some of.
Oh, I think you got muted.
Sorry for the background noise. My question was, or my suggestion was, from the list of the projects that have been submitted, which ones would be like appropriate to add the secret network or the randomness?
Yes. So it's basically just any application you want to build that uses Secret as a privacy layer. So examples are like voting or auctions or NFTs or real world assets. Like, for example, an application, a demo that I'm working on next is showing how you can mint your home address as a real world asset that's stored in a secret contract, because you don't want people to actually know what your address is, but you can claim it. But you want to keep that information encrypted in a secret contract. And so for this hackathon, we're just really trying to see just that Lisk developers are adding this cross-chain functionality to their applications. So if you have an existing dApp you've built on Lisk, you can just port it to Secret Network using this, what I just showed you during this tutorial, and then submit it to the hackathon, and you'll be eligible for prizes.
Okay, awesome. I think most of the projects can qualify for addition, like if they are able to add like a feature from Secret.
Amazing.
Also, if you would love to walk me through the dApps and also provide feedback or maybe some use cases they could use, I'm available to do that as well. You can just schedule call my calendar and then work through the dApps, and I could give you ideas of or use cases of what you can integrate. And as well, the developers as well, they can reach out to me anytime if they need any support or they need maybe more technical support. And of course, there's also there's another workshop coming up on 5th, which is a Wednesday. So that's going to be on secret part. So yeah, you can get to learn more about how to integrate some of these use cases as well. I would love to have those guys as well on the course so they could, see for themselves.
Awesome. Pope, thank you for creating this space today for us just to be able to share code and discuss. And good luck, everyone, with your hackathon that's ongoing right now. And I really hope that you participate in Secret Hackathon. Really looking forward to seeing apps that are built with Lisk and Secret together.
Yeah, I'm also waiting for you guys to win some prizes as well. So we'd love to see you guys bagging more prizes. All right, thank you very much, Shin, for today's workshop, and thanks to every developer here as well. Thanks to Charles as well for making this possible. See you guys on Wednesday. And please do join the Telegram group. And if you have any question, feel free to reach out to me or send Shin a DM on Telegram. Thank you, everyone.
Bye-bye.
Bye bye.